Hey everyone, in this video we will start talking about data modeling and the benefits of star schema. So we'll go and we'll start with what happens if you have one big flat table and what are the problems or the challenges you could face with that. So there is redundant data, so you could have the same data replicated across multiple rows, so it leads to redundancy. That's a big problem. There's a maintenance or maintainability challenge. So if there's any change to a small part of the data model, or let's say if you change the logic for one specific column, you have to run the test cases for that entire big table. It's a big problem in terms of maintainability. Because it's one big table, as the size grows, the query performance is going to suffer. So that's just another challenge there. It's not scalable. So it's not scalable because you can't test it. More data leads to query performance issues. There are other issues that you could face with just a flat structure. So it's just not a scalable model per se. And then we've got flexibility. It's not a flexible model. You can't make changes easily. And there are benefits to normalization which are not available with this one big fat table. So that's one of the challenge. It's not normalized. So let's just continue and step back. So you could probably normalize this, and you could have a star schema. You could further normalize it into a 3NF, which is not recommended, but you definitely want to get to a star schema, and that's what the Microsoft recommendation is with how you should do a model. Now let's just go ahead. So what are the benefits of a fact table? So a fact table accumulates rows that represent observations or events that record a specific business activity. So that's what a fact table is. So for example, sales amount, stock balances, sales quantity, water usage. These are all examples of facts. So the fact table is sitting in between. It's simple and understandable. So you can say, hey, this is my table which just talks about sales quantity or sales amount. It's because you've broken it up and just got numeric values in a fact table. So it's a smaller set of columns. So it's better performance. It's scalable, just because it's you can test it better. You can increase the size. You can add more functionality, but it's definitely scalable. There's flexibility to reporting, which comes as a side effect of having a fact table, but it also comes as a side effect of building dimensions. There's a lot more consistency and consistency and accuracy. So you can test what's going on. It's very easy to test back to even the source tables. And you can have consistency and accuracy. There's support for aggregation, so you can quickly aggregate from a lower level to a higher level, because you can join two dimensions and you can run up and roll up and roll down. Facts can easily be integrated with data warehouses which have confirmed dimensions, and the benefits start coming as you build more and more confirmed dimensions. And then there is ease of ETL and historical analysis. So facts build historical data over a period of time, and you can analyze all of that. And there's ease of ETL as well. So for a specific business case, once you've built a fact table, it's easy to build the ETL because it's less logic, because fact table by its very nature contains less logic. Moving on, we'll talk about a dimension table. A dimension table is a table that contains descriptive attributes or dimensions that provide context to the quantitative data stored in a table. So for example, you could have customer name is a descriptive attribute. Calendar year is a descriptive attribute. A product name is a descriptive attribute. Region name is a descriptive attribute. Geography is a descriptive attribute. So you get more context to information. So let's say I've got sales, but then I can link it to a customer, and customer belongs to a specific geography. So I start getting, hey, what's the sale in a particular geography? There's improved query performance, obviously, because you've broken your table up. So it's and you only get what you want by joins, and you can filter out the tables as well. You've got it facilitates online analytical processing, so you can roll up, you can roll down, or you can traverse hierarchies. So that's a lot more simplified because you have that in a dimension table. You can enable hierarchy navigation. The SQL queries you write are a lot more structured as well. You can enhance data quality. You can specifically check for confirmed dimensions. You can put in master data management tools on top. So that's one of the benefits. There's support for historical analysis. Again, you can build type to slowly changing dimensions, and you can go through that maybe on a Wikipedia article, but it's something that you can definitely leverage. Then there is ease of maintenance. So it's easier to maintain because it's just a smaller subset. You can build better test cases for it, and the ETL is not as complicated, so it facilitates the ETL process. And obviously there's improved understandability. So you could have one customer dimension, one you could have geography dimension, you could have a date dimension. So you can navigate it and say that all the verbs, for example, is a fact table, and all the nouns would probably sit in a dimension table. So if you wanted to think through that, that's one way of thinking through it. And it essentially translates in. So it essentially translates into a fact table, which is a star schema, and star schema is what we are recommending here. So we've basically in this video gone through the benefits of a star schema. Vis-a-vis, we looked at the fact table and the dimension table, and what are the problems we could face with an a flat table. So I hope you find this video useful, and thanks for watching this video. Please do subscribe to my channel and like my videos if you enjoy what I'm doing. Let me know if you would like me to take any specific topics. Cheers, bye.